So let's do this next example. So 3x over x squared plus x minus 2. All right, so let's go ahead and set up the problem. And let's start off with factoring it. So 3x divided by, so x here, I'm going to have a 2 and a 1 there. And this should be a positive, and this should be a negative. All right. And now what we want to do is break it up into two fractions. So a over x plus 2 plus b over x minus 1. So this is what we really want it to be like. All right. So now again, now that we have it in this form, what we're going to do is multiply every single little thing. So right now, let me go ahead and set up the problem one more time. So 3x over x plus 2, x minus 1 is equal to a over x plus 2 plus b over x minus 1. What we're going to do is we're going to multiply everything by the degree of, not the degree, by whatever the denominator is. Okay, and the denominator is that. So every single little term, to kind of get rid of the fractions, I'm going to multiply everything by that. So I'm going to multiply this guy by x plus 2, x minus 1. This guy by x plus 2, x minus 1. This guy, x plus 2, x minus 1. So you can see that this guy cancels out. So you just are left with a 3x. For this guy, the x plus 2's cancel out, so you're left with a x minus 1. This guy, the x minus 1's cancel out, so you're left with b x plus 2. So you have 3x is equal to, so you have ax minus a. And now we're going to have plus bx plus 2b. Okay, so we're going to have that. Now let's go ahead and equate our coefficients. So let's gather everything that has x's. So this 3x, the ax, and the bx. So we're going to put this all together. Now remember that in our previous problem, the x's didn't really matter. So we only care about the things that are in front of the x's. So here the things that are in front of the x's is 3, the a, and the plus b. That's all we really care about. We only care about the coefficients. We don't care really what x is equal to. And actually, we can't really find x because this is not an equation. And then we're going to go ahead and equate everything that doesn't have an x. So, but if we take a look at it, we got a negative a, we got a positive b, but then we have no constant on the other side. So there's nothing over here. There's nothing over here that has a no x. So we're just going to put 0. We're going to go ahead and put a placeholder at 0. So that means whatever the sum of these two guys are, they have to be equal to 0. Now notice here we can use elimination. We can go ahead and eliminate the a's immediately. So if we add these guys up, these guys go away. So you get 3 is equal to 3b. So now we're going to divide by 3, and we get that b equals 1. So now let's go ahead and figure out the next a. So I'm going to use the first equation, the 3 equals a plus b. And I'm going to plug in b equals 1. So I'm going to subtract by 1, and I get that a equals 2. So that means that my answer, so if I plug that in, you're going to get 2 over x plus 2 plus 1 over x minus 1. So that means if I were to combine these two, I'm going to end up with 3x over x squared plus x minus 2. All right. So this should be very mechanical, but I think the question now arises of like, okay, so this is cool if this can be factored, but what about if this is not factorable? Or what about if it has repeated factors? So for example, we have problems that when they factor, like x plus 1, right, and x plus 1, like let's say we got that, which is also equal to x plus 1 squared, how would we go ahead and deal with something that looks like that? Or how do we deal with things that maybe are not as factorable as we think? So for example, this guy is not factorable. So how do we look with things that look repeated and things that are not factorable? Okay, also this guy is not factorable too. So how do we deal with these cases? All right, so this is going to be a little guide to kind of help you. So this obviously I grabbed from the internet. I did not create this at all. So basically what it's saying is that if you have a sum of two, if you have two different types of factors, you're going to get a over x minus a plus b over x minus little b. Okay, so this is if you have two different factors. If you even have three different factors, that means you're going to have three different variables. Okay, so or three different terms. Okay, so how many factors you have in the denominator will determine how many partial fractions you're going to have. Now here is the new one. So if you have a repeated one, so let's say this guy, you ended up getting a repetition. So like a multiplicity, right? So the way that we're going to do it is that we're going to write the first one as x minus a to the first power plus b over x minus a to the second power. Okay, so similarly, let's say you had something that looked like this, like something over x plus 1 to the fifth, let's not make that, maybe to the fourth power. Well, what that means, let's say we had 2x up there, that means we're going to have an x plus 1 to the first power, then we're going to have an x plus 1 to the second power, x plus 1 to the third power, and then we're going to have another one, x plus 1 to the fourth power. And we're going to, so we continue adding fractions until we end with the repetition. Why? Well, basically think about all the different common ways, common factors, or common ways that you can get x plus 1 to the fourth power. You can get it with an x plus 1, you can get it with an x plus 1 to the squared, x plus 1 to the third power, x plus 1 to the fourth power. So sometimes you're not going to get numbers for all of these guys. Sometimes you might end up getting a couple zeros, but you just want to make sure that you include all possible variations of how you can get x plus 1 to the fourth power, this repeated thing. If you have a combination of repetition and just a single non-repeated root or non-repeated factor. So you're going to do the repetition first. So you can see here you got x minus a squared. So you're going to do the repetition first and then end it with the one that's not repeated. Okay. Now what about if things are not factored? So if you have something that's not factorable anymore, so something like this. So here I gave you, so the first guy is basically factorable. So this one's good. But this one's not factorable, and it's actually a quadratic. A quadratic that's not factorable. So the way that you're going to do it, you're going to write the non-factorable part on the bottom. So this one, remember, this is not factorable. But what you're going to add on the top is this bx minus plus c, so this linear term. So that's the only thing that has to be done. So you have to write this linear term for things that are not factorable. Okay, so again, be very careful with this last thing. All right, so let's practice just by writing some of the partial fractions without having to evaluate them. So here, write but do not evaluate the partial fractions. So here we have 2x minus 3 divided by x minus 4, x plus 1. So notice on the bottom, nothing is you don't need to factor anything on the bottom. Everything is factors for you. Nothing is repeated. So this is actually a basic partial fraction. It's just going to be a over the first factor plus b over the second factor. So there was really nothing to this problem. That's just basically it. Now this next one, 1 over x minus 2, 2x plus 5 to the fourth power. So I have a basic, a non-repeated factor. So that's just going to be a over x minus 2. And now you have a power of 4 that's repeated. That means we're going to have to write this 4 times. Okay, so the first one is going to be a regular 2x plus 5. The next one's going to be a 2x plus 5 to the second power. The next one's going to be 2x plus 5 to the third power. And the next one's going to be 2x plus 5 to the fourth power. And think about it this way. Well, how can you get 2x plus 4? You can get a 2x plus 4 to the first power and a 2x plus 5 to the third power. So this is a good combination. You can get a 2x plus 5 to the second power. You You can get a 2x plus 5 to the third power and a 2x plus 5 to the first power, or you can get a 2x plus 5 to the fourth power, or you can have all of them. Okay, so you have to look at all the possible combinations in which you can get this guy. So on the top, all we just got to do is write the letters. We already used A, so this is going to be B, C, D, and E. Obviously, I will not give you something like this on the exam. This would be really, really hard and a really long way to do it. Okay. Now, what about this guy? You see not repeated factors. Be careful, this x is still a factor. You can kind of think about this as the denominator as 1 over x minus 0, x plus 1, x minus 4. So you can think about it that way. So be very careful that this guy is also a factor. So this is just going to be equal to a over the first one, which is x, plus b over the second one, which is x plus 1, plus c over the last one, which is x minus 4. None of these guys are repeated. And now let's look at the last one. So you got a couple repetitions. So remember, this x is still a factor. It's repeated 3 times. You also have another repetition of x minus 4 to the third. And then you have this last one that, and this doesn't look factorable at all. Okay, so the first thing is let's deal with the x plus 3, x cubed. So that's repeated 3 times. So you're going to have an x squared, and an x cubed. And this one you're going to do an A, B, C. So that's for this guy. Then we have this x minus 4, which is repeated 3 times as well. So it's going to be x minus 4 squared, and x minus 4 cubed. D, E, F. And now we have our last thing that's not repeated at all. That's not repeated, and it's not factorable. So we're just going to write the same thing because it's not factorable. I can't factor this guy. And we're going to write a linear term on the top. So A, B, C, D, E, F. The next one's G, X, A, B, C, D, E, F, G, H plus H. Okay, so this whole thing will be my partial fractions. Okay, obviously doing this problem would be pretty horrific to do. But that's just how you would go ahead and write all these little terms out. Okay, so in the next video, we will do a couple more problems just to make sure that we feel a little more comfortable. Some with repeated factors and one with a non-reducible term.